Evet, Kaliningrad, Kakdela. I wanted to make a smooth transition because I was told this is the only English presentation. But my Russian is limited to this. I'm sorry about that. Today, I'm going to talk about building a production-ready progressive web app with Angular and FIREBASE. A small introduction about myself. I work as JavaScript squad lead for a consulting company called Linkit in Netherlands. I'm also working for KLM, Royal Dutch Airlines in Netherlands via Linkit. And I voluntarily help ITNX and GDGNL organizations by co-organizing events and speaking at them. Before moving forward this state of the progressive web app development, I would like to know how many of you actually heard the term progressive web app. Yeah, I think we need a small introduction. It's a quarter of the audience. Progressive web app is a way of building native-like mobile and desktop applications with web technologies by utilizing some of the web APIs. Web APIs like service workers, push notifications API, background fetch API, background sync API, web app manifest file. By using all these APIs together, you try to build a native-like experience on mobile devices or on your desktop device based on web technologies. I would like to start with showing you the number of progressive web apps as of June 2018. Thomas Steiner from Google did a meta-analysis on HTTP archive to come up with this analysis. And based on his analysis, there are more than 6,000 progressive web apps in the web. It should be more now, but there is no up-to-date analysis yet about this. And this shows average PWA scores. These scores are based on LIGHTHOUSE score. LIGHTHOUSE is a CLI tool and also DEVTOOLS tool built by Google. I will talk more about that in the next chapters. It scores your progressive web app from 0 to 100 to show how performant, how native-like your progressive web app can be. And these numbers are around 80 for most of the progressive web apps published on the web. We still need a room over there to improve our scores. And currently, Google works on a project called FUGU. This project started by Google a couple of years ago to fill the gap between native mobile apps and progressive web apps. The idea is delivering some capabilities catch up with several in-flight APIs. And especially this year, you can see the roadmap for delivering some of the APIs. And there's also live documentation for the current status of APIs being developed by Google. You can visit this link and see the current status. And these APIs are especially important for your progressive web app to be more native-like because it provides some good APIs like badging API. It shows notifications, for instance, on your desktop, on your progressive web app. You can use it for push notifications or another reason. There's also contacts picker API, which allows you to pick some contacts from your mobile phone while using a web application. So these are pretty cool new APIs. And Google is also built this website. It's a capabilities webpage. When you visit this website, you can see the whole idea of this project FUGU and the capabilities movement. And at the same time, there's a link down below the page, a code lab which you can take to experiment with these new APIs. Angular has a great set of tools for developers to help them scaffold code via something they call schematics. Schematics is a way of scaffolding code for your project. And while building a progressive web app with Angular, we can utilize schematic of Angular for building a progressive web app. It's called Angular PWA schematic, and you can add this to your project by running this command ng-add Angular PWA. So it will give you a head start on your PWA journey, and I will talk about platform optimizations you need to do, and I will also give some more information about service worker architecture of Angular. This is my friend Dogi. He's going to guide us spiritually throughout this talk, and we will see some tips showing up every now and then. This is a tip from Dogi. He advises us to use npx command because then you don't have a conflict with your system dependency and project dependency. When you add Angular PWA schematic, these are the files automatically generated for you. All these new files come from running that single command. And there are also more changes on your Angular JSON, index HTML, and app module TS files. We should start our optimizations by changing web app manifest file. Web app manifest file is a JSON file that tells the browser about your web application and how it should behave when it's added to home screen. When you add your PWA to the home screen of your mobile device or your desktop device, it will behave based on the declarations on this file. It looks like this. It has name, short name, theme color, background color, display, scope, start URL, and icon definitions. This is a typical manifest file. And it's also the file generated automatically for you when you add PWA schematic. To inspect the web app manifest file, you can use Chrome DevTools Applications tab, and then you can navigate to manifest on the sidebar menu, and you will be able to see the output of your manifest file on the right side. One of the improvement points that I see on top of the manifest file created by Angular PWA is adding the description field. It doesn't add the description field for you, although it's a standard. It's a standard on W3C, and also it's documented on MDN. And more importantly, by providing this description, you satisfy the criteria for Microsoft to automatically index your PWA and package it for their store. So when you provide a name, a description field, an app icon that is at least 512 times 512 pixels, then Microsoft will automatically index your PWA and it will package like a native application in their store. Another improvement that you can do on web app manifest file is adding a query string parameter at the end of start URL. By doing this, you can track how often your installed app is being launched on user's home screen. Displaying add to home screen guidelines is also important because that helps your users to be engaged, and it's a way of installation for progressive web apps. Progressive web apps are installable without having the hassle of going to app stores, downloading content. It's basically creating a shortcut for your application. You need to meet with some of the criteria of Chrome and Android, for instance, to automatically show an install banner or mini info bar and allow users to install this shortcut to their device automatically. The current criteria for add to home screen on Android is the web app should not be already installed. It should meet a user engagement heuristic, and current heuristic is having user interacted with the domain for at least 30 seconds. It should include a web app manifest file that includes short name or name, and icons must include 192 pixel and 512 pixels size icons. It should include a start URL, and display must be one of full screen, standalone, or minimal UI. And it should be served over HTTPS. And it has a registered service worker with a fetch event handler. It might look a lot, but you actually get most of them for free when you use vendors like Angular and FIREBASE. FIREBASE is automatically served over HTTPS. And the manifest file and service worker created by Angular already satisfies these criteria. Short name field in your manifest file represent your PWA's name when it's added to home screen. And additionally, name field will be used in add to home screen prompt. Such add-to-home screen functionality doesn't exist on iOS, but luckily we can build our own UX to guide users towards the required tabs to help them add your application to their home screens. It can be a good old pop-up, or even better, a mini info bar which mimics Chrome's behavior on iOS to create a uniform experience across platforms. Here's an example for a bit of code that is used to create a mini info bar. As you can see, it detects if it's in standalone mode, and then it also tracks if the banner is shown to the users. We don't want to annoy users for showing this banner a lot of times. And then it presents a basically UI element. Such UI element can look like this. So you're basically navigating your users towards the clicks that they have to do for adding to home screen on iOS. Adding meta tags for platform optimization is especially important for iOS because there's a lack of standards on iOS at the moment. Although many browsers adopted web app manifest specs, WebKit, especially mobile Safari on iOS, currently uses a non-standard track meta tag implementations for adding icons, splash screens, or setting the theme color. Support for the web app manifest is poor and undocumented, and implementation doesn't make any use of the manifest for icons, orientation, splash screens, background color, and some events. Because of that, Apple's iOS doesn't create a splash screen or any app icon for PWA automatically, like how Google's Android does. This prevents your PWA to provide a native-like experience on iOS. But there are ways to provide these native-like experiences. Fortunately, there is a workaround to configure app icons, splash screens, and status bar of your PWA on iOS platform. The workaround is adding custom meta tags to your application's index.html file. These custom tags are documented on Safari Web Content Guide. You can see the link here. But as an advice from Doggy, you should keep an eye on WebKit feature status for tracking the progress of implementations of web standards. Once Web App Manifest standard is implemented on WebKit, it would be possible to not provide these custom meta tags to provide theme color or icons for your progressive web app. You can track the progress such API development by visiting this link. It's currently in development stage. But until then, we need to add these custom tags. This code demonstrates how you add an icon for iOS platform for your PWA. You need to create these meta tags and you need to generate icons. You can see two different apps on iOS when an app icon is provided by meta tags. So this demonstrates a PWA without an app icon. And you can see another PWA which provides these meta tags and it has the icon as it should have. If you don't provide the icon, it will just take a screenshot of your web application, like the one on the left. Apple uses custom link with a rel called Apple Touch Startup Image to support splash screens for an app added to iOS home screen, as you can see from this slide. In order to add splash screen to your PWA on iOS, you must add a meta tag that points out an image for a specific resolution and orientation. So this can go for 20 or 30 lines because these are the devices that you need to support for supporting all the devices on iOS. And not so good news, you need to add a meta tag for each resolution and orientation. So in total, it's about 20, 30 meta tags. But Doggy is here for help. It advises us to use an automated tool. Actually, I was advising another tool before, but recently I published an open source CLI tool just for this reason. It creates app icons and splash screens for your PWA based on just an SVG file or PNG file you provide. And by navigating to index HTML and manifest JSON, it also makes necessary updates. So without any hassle, you will have compliance with both Android and iOS platforms. You can visit the GitHub page of the CLI by visiting this link. And this is a demonstration of two different apps, one with splash screens and another without splash screens. So it's just blank without any splash screen. It's not native-like and not so nice. Splash screens are also used when your application is in the background. And on iOS, there's another way to customize the status bar of your PWA. So you need to use another meta tag with another rel. And Apple doesn't provide a further customization rather than 3 options for you. One option is white, displays white status bar with black text and symbols. Black displays black status bar, and black translucent is transparent. You can see the differences of three options here. Service workers. Service workers are the backbones of a progressive web app. So it allows your application to be offline capable. It allows your application to be more resilient. And Angular has a nice architecture for building hassle-free service workers for your progressive web app. And by adding Angular PWA schematic, you already get advantage of using service worker automatically generated for you. You just need to configure a manifest, but I will talk about that later. So this configuration file, ng-sw-config.json, which is created for your application when you add the schematic, it specifies which files and data URLs that Angular service worker should cache and how it should update the cache files and data. The concept of asset groups is used by Angular service worker architecture to cache your assets on install or on update based on 2 modes. The modes can be prefetch or lazy. Prefetch mode, it tells the Angular service worker to fetch every single file while it's caching the current version of the application. This is bandwidth intensive. The resources, it ensures that the resources for your application is available whenever it's requested. For instance, when you add it for the first time to the home screen, the application shell, the assets main layout of your application will be already cached. So even though your device is offline, you will be able to open the application. And there is lazy mode. Lazy mode doesn't cache any of the resources upfront. Instead, the Angular service worker only fetches it when it's requested. You can also use it for updates. It behaves different on the update. Lazy tells the service worker not to cache those resources at all until they are requested again, and then they will be immediately replaced. This is a sample configuration for application shell. Application shell is an architecture for progressive web apps to provide the layout of your application without any data, without further JavaScript files. It's the core layout dependencies of the progressive web app. As you can see, the core layout for a web application is basically an HTML file, a CSS file. In Angular environment is vendor.js, main.js, polyfills, and runtime.js. So by providing this configuration, you make sure that once your application added to home screen, it will be caching all these files. And another example of a different asset group is UI assets. For instance, this one uses asset files like some images and SVG files and maybe some further fonts that are not required on initialization. And you can also use CDN links as URLs. When you use a caching strategy, you must exclude the resources that you would like to keep fresh, such as additional service worker files that your application might use. And you can use glob-like patterns like this one, explanation mark slash star dash sw.js. Then it will exclude all the files ending with dash swjs. As of today, Angular service worker architecture doesn't provide a composition of different service workers. So if you want to extend the service worker logic provided by Angular, currently there is no way by using Angular environment. But there is a workaround. You can introduce your own service worker by replacing the generated service worker for your application. When you add Angular PWA schematic, so it automatically makes this change on your app module TS file. So this is automatically generated service worker file. You don't see this file, it's in distribution folder and it's created on build step. You don't change the file, you just configure it on JSON and Angular's build system will generate this file. But you can change this in app module TS file and you can include your own main service worker file, which is kind of an abstraction for this one. This will include the one generated by the Angular, so it will be the same. So this is the default field when you add the schematic, and we change this default field with main SW. And main SW includes the Angular's generated file, and then maybe a custom service worker. And for instance, if you like to show push notifications, there's a notification service worker. So you can utilize service workers and you can introduce your own logic via service workers like this. And using Chrome DevTools application tab, you can navigate to service workers here. And then you will see the attached service workers to your application. In this scenario, we have main SW file. So it's also attached. And there is FIREBASE messaging service worker for this example application. So it can handle cloud messaging for push notifications, and it will be using Angular service worker under main SW file. So this is the closer look. And you also see the status of the service worker. You can update it or unregister it manually if you like, and you can test push and sync manually. And updating your PWA, as I said, service worker is the backbone of a progressive web app, and updating a progressive web app all starts from your service worker. Browsers regularly check for byte differences for service workers, and if there is a new service worker, it waits in the queue, and you can show your users that there is a new version, there is a new service worker, and they can choose manually updating the application by basically reloading it, or they can just ignore, and once user closes the application and starts it again, reloading it, then it will be using the new service worker, aka new version of the app. In the context of an Angular service worker, a version is a collection of resources that represents a specific build. So this is a manifest file which shows whole details about your build, like all the assets, all the hashes, and even one single bit changes on this file, it will be known as a new service worker. So it will be introducing a new version for your app. At any given time, the service worker may have multiple versions of the app in its cache, and it may also be serving them simultaneously. This is how Angular's service worker architecture manages this. If you want to build these manually by writing native service worker code, you need to introduce a lot of boilerplate. Sorry about this animation. Something is wrong with the clicker. Yeah, and this is how you can provide the version information for your PWA. Angular Service Worker architecture also recognizes app data and providing a version and any custom field in your app data. So it can be anything basically. you can get this data, app data, via service worker update service of the Angular. We will be using this information to show a notification to the users to let them manually update the application. Angular handles its service worker updates via its own service called service worker update from Angular service worker module. And you can subscribe to events, and then you can get the data from your app updates, listening to your app updates, the app data fields. And this is how it looks. By using app data, you can actually replace this text by providing a version information and changelog information to the users. And this is handled automatically. So if anything changes in your build manifest, then this will be shown as there will be a new service worker. And then they can choose to refresh now, or they can click cancel, which means it will be refreshed when they reopen it. Configuring Angular JSON file for static access is also important, especially if you extend the service workers. So these are the default modifications on your Angular JSON file when you add Angular PWA schematic. It adds manifest JSON as an addition to assets. And you may also want to include this to include the service worker abstraction and any other service worker you introduce to the build system. This is also crucial if you want to implement your own logic on service workers. You need to make sure all the service worker files will be put to output folder at the root of the build folder. And if you use any libraries in one of your service worker files, for instance, I use for one of the PWAs I built, I use IndexedDB keyval library. Then I also need to put that in the root of the folder. So that's how I extended it. Angular's config files use glob-like patterns to match file names. This is another tip. So you can use this one to match all the HTML files, for instance, and this one to only match the files in the root, and this one to exclude all the source maps. Once you're ready with your implementation, it's time to host it on a provider like FIREBASE. FIREBASE built around simplicity, and it's quite easy to set up a hosting and configure deployments for your application. And I will provide the steps you need to follow on the next slides. Once you're logged in service worker once you're logged in FIREBASE console, you can click on Add Project button and fill this form with your preference, selecting region for your hosting and providing the name. And after creating your project, you can navigate to Hosting tab under Develop category, and you click Finish on this prompt. When you go to Hosting, you need to click Finish, and then you will make your project available on FIREBASE CLI. An easiest way of using FIREBASE services is to make use of FIREBASE CLI through the console. To access FIREBASE CLI on your command line, you can just install it globally or run one of instance of FIREBASE by running npx. And then it will ask you for initialization. So you can choose you want to use the hosting service. So you will configure the hosting for your site. And this is the output once you created the hosting. So it initializes two files for you, one FIREBASE JSON file and FIREBASE RC. FIREBASE RC is the configuration for your FIREBASE account and FIREBASE services. And FIREBASE JSON file is the configuration for the services you use. For instance, we are going to configure hosting, especially for our PWA, by using this FIREBASE JSON file. So this is the FIREBASE JSON file content for configuring your hosting. Since this is a single page application, we need to use this rewrite. So any of the URLs coming into the server will be mapped to index.html. And we are ignoring some of the files here. And this is the Angular's build folder that we are actually deploying to Firebase eventually. Very important tip from my friend: do not deploy in any file that keep your credentials or any other confidential info under no circumstances. Make sure to ignore any configuration file by using that ignore field. Otherwise, you can end up a disaster like this. So this is a tweet about the attention on this big security concern. And you can also extend this Firebase hosting configuration by adding custom HTTP headers for the caching. By providing long-time caching, for instance, this is the output of a long-time caching of your assets. You can use this header, cache control max age to 1 year, to provide long-time caching for all the assets you built via Angular's build system. Normally, you should be careful about doing this because you should also care about invalidating your caches. But Angular builds all the assets, all the files for you by adding its MD5 hash at the end of the file name. So if you change anything, any bit on that file, it will create a new file name. Hence, the earlier cache will be replaced with a new one. So you don't need to care about invalidating your caches. Another tip from Doggy is introducing vendor chunks to your Angular application, especially for your production builds. This will help on your PWAS cache strategy, as you most likely will not update vendor libraries too often. So you will be developing your application logic in your main JS file on your build system. But if you separate the vendors, you're not going to update Angular every month or every week, right? By enabling vendor chunks, you can see there's a new file vendor.js created, and this can be cached by introducing long-time caching. So you don't, and it's a big chunk. You don't need to load it again and again. Deploying your progress web to Firebase is very simple. Once you have this configuration, you just run this command, Firebase deploy, and then it will deploy your application to Firebase based on your hosting configuration, and it will show all the logs, and eventually deploy is complete, and you can access the application by following the link. Recently, there's a new way of deploying Firebase application was introduced to Angular ecosystem. So there is a new schematic called Angular Fire. You can use this schematic without using CLI at all. So if you have Angular application, just add this schematic and then run ng your app and then deploy. Then it will be using Firebase CLI underneath. Once you have your PWA ready and you deploy it to a remote server, it's time for an audit. And you do audits for your PWA using an online audit runner called LIGHTHOUSE. This is an open source tool from Google. It comes in 3 shapes. You can use a CLI, you can use it on Chrome DevTools, and you can use it online. To use it online, you can just visit this link, developers.google.com/web/tools/lighthouse/run, and then you put a URL, and then it will run the audits for you. During development, you can navigate to your audit section, and then you can run a Lighthouse audit via the DevTools, and then it will show you all the past audits and all the problems you have on PWA. So it will guide you through fixing these issues to provide a better experience for your users. And this is how CLI is used. So you can just call npx lighthouse and then your URL, and you can run it headless. And it shows performance, accessibility, best practices, SEO, and PWA audits for your application. And it will create an HTML output for you. Another tip from my friend, executing nightly regressions on your production app to monitor it against updated PWA audits and also any change affecting regressions on your PWA. You can introduce a CI step. You can introduce Lighthouse CLI to your continuous integration pipeline. And every time you introduce a change, you can validate if your PWA still passes all the audits. It's possible.
Окей, время вопросов. Пожалуйста.
Questions?
Yes, hello, my name is Anton. First of all, thanks for your speech. It was quite interesting. I have one question. I've played a little bit with PWA applications and always face the same problem. My application started from time to time in windowed mode or full screen. So can you maybe help me? What was the problem?
Sure. I think it might be related to your declaration on manifest JSON file. You need to use standalone fields on the manifest JSON file. Then it will make sure it will start on the full screen when you launch it from the home screen. Because based on the configuration on that field, it starts in a full screen mode or in a window mode. So it can affect what you're trying to achieve. And by the way, tomorrow there will be a workshop about the same content. We are going to take an Ionic application, a typical regular web application, and we will convert it to progressive web by following all these steps. So we will do it in 10 steps in 2 hours. If you're curious about it, join me tomorrow at 1 p.m. And we can do it all together and see if you face any issues. Yes, please.
Hello, thank you for your presentation. Sure. First of all, one question. You said about you use the FIREBASE, yes?
Yeah.
Maybe another system to use the PWA, like Heroku or something else. Do you use it?
I personally don't use it, but you can basically use any hosting provider. It's a static.
Not only FIREBASE, yes?
Not only for FIREBASE, no. Okay. But you need to make sure about your rewrite logic. So when you configure a hosting service, you need to make sure the rewrite logic is ending up with your index.html so that it will act as a single page application. And it should be configurable by considering the extended configuration, hosting configuration we provided for FIREBASE. That makes difference. Yes, please.
Hello, my name is Kirill. Thank you for your report. I wanted to ask, is it general recommendation to use PWA over the just usual caching strategy? What are the advantages of using PWA if we just exclude ability to use, I don't know, context API in our phone or some abilities to use phone operation system API?
Can you please repeat again?
I just wanted to ask, is it highly recommended to use PWA, but not just use common caching strategies in your usual sites and browser?
PWAs are not all about caching, so you shouldn't see PWA approach as a caching solution. Caching is one of the capabilities that it can provide via service workers. So you interrupt all the fetch requests you have via service workers, and hence you can serve your cache assets via it. If the only requirement for your application is caching, PWA shouldn't be a solution for it. You should consider your other options. Of course, you can try a caching strategy via your service workers. You can also use, for instance, if you don't use Angular, you can use another library from Google as well. It's called Workbox. It comes with a lot of caching strategies, so you can choose whatever fits in your caching strategy, and it works via service worker as well. But it doesn't mean that your application will be PWA still. So you can still add service worker to your application without making it a PWA. PWA is like progressive web app, and progressive means you enhance your web application progressively. So you can just use one of the web APIs if you don't need any other. For instance, if you don't want to provide a native-like user experience via adding to home screen, you can ditch manifest.json file, just use service workers for the cache. Or if you want to show some notification badges, just use badging API. So it's not all in or nothing. So you can choose your options.
So silent. Еще вопросы? Можно на русском.
Yes, please.
Hello. I have a question about delivering your app. As you said, the app can be in Microsoft Store. Also, I know it can be in Google Play Store. So what about iOS App Store?
Currently, it's not possible to put it on iOS App Store. Apple is completely against this idea. There was a recent discussion on Twitter about this. I think it also conflicts with their business strategy. So I'm not sure if at any point of time it will be possible to add PWAs to iOS Apple Store. But Microsoft and Google are pioneers for progressive web apps, and you can put your progressive web app as an application in both stores. And you can do that without much hassle. For instance, for Microsoft Store, you just need to meet the criteria and it will automatically index it. For Android, it's almost the same. If you want to extend the capabilities of a PWA, that's also another option. There's a web APK for Play Store, so you can put your PWA as an application and you can extend its capabilities by adding further Android code on top of it. That's also possible.
You talk about the PWA application in Angular framework. What about another frameworks? React, Vue, or, oh my God, native JavaScript or something like that?
I specifically chose Angular for this talk because Angular abstracts the whole complexity of building your caching strategies, building your service worker logic, and it just provides you a couple of options. You have asset groups, you have data groups, you have two different strategy, freshness or performance, or prefetch or install mode. But if you're building for any other environment, you can use native implementation. So you don't have to use any other libraries. But using native implementation also comes with a cost. You need to create a huge boilerplate code, for instance, to simulate the same caching algorithm. You need to interrupt the fetch. You need to introduce your cache. You need to invalidate your caches. You need to provide different strategies per different files. There are a lot of code. That's why Google also built this library called Workbox. Workbox is a library which you can use for any type of application. So even not using any framework, just vanilla JS, you can use Workbox still to get help for not building this boilerplate yourself. So it will create all the routing, all the caching algorithms for you.
Thank you.